Okay, on this homework problem, we're going to take a look at using StatCrunch to do a two-sample hypothesis test. The way we know that that is the problem we're looking at is that P1 equals P2 is our claim. So we're looking at two different groups, in this case, a particular drug test, treatment and placebo, and we're looking to find out if the proportions are the same in those two groups. So we're going to go ahead and click on StatCrunch, and we're going to go to proportion, two sample with summary. And we're going to return to our data set and take a look at, so we can drag this down a little bit here, take a look at the data that we have. So in the first data set, we have 70 out of 700. In the second data set, 90 out of 720. Now you can add the 70 and the 90 and divide it by the sum of 700 and 720. That's what's called the p-bar or the pooled estimate. You can also find the individual p hat for the first one, p hat for the second one. We're not doing that right now, but sometimes the problem might ask that. 70 divided by 700 is 10%. 90 divided by 720 is 1 out of 8 or 12.5%. And so we're comparing to see if they're the same. So the assumption here is that P1 minus P2 is 0, or that they're equal to each other. The difference is that they're not equal. And we're going to go ahead and click compute. And we take a look at our p-value. Our p-value is 0.1363. The level of significance in this problem is 1%. So we fail to reject HO because our p-value is not less than our alpha. Now the other piece of this problem is that it does ask for critical z values. And just as a quick reminder, this goes back on chapter 6. You would go to calculator, normal. And in this particular case, you're going to put 0.5% at either end because it's allowing a total of 1% error. So we would be using 2.575 at one end and 2.575 at the negative 2.575 and positive 2.575. Those would be our critical values. Okay, we're going to take a look at a different type of question now. This particular question is about diets. There are 39 subjects used at diet 1 and 39 doing diet 2, and we have the weight losses. This particular question asks us to find the 95% confidence interval estimate of the difference between the two population means. So again, we're going to click on StatCrunch. This time we're looking at a two-sample t-test. So we're going to enter the data into those boxes. So the first one, the sample mean was 3.3, the standard deviation 6.6, 39 people participated. The second one, 0.8, standard deviation 6.3, 39 people participated, and they want to find the 95% confidence interval. This next sentence is critical. Do not assume the population standard deviations are equal. That means you are going to uncheck the box that says pooled variances. So make sure that this box is not checked. Okay, go ahead and click compute. And we now have a confidence interval. They want us to round to 3 decimal places, so we would come to these numbers and round them to 3 decimal places. And basically what happens is this, folks, because this interval includes 0, that's basically saying that there's no difference in the population means. The third type of problem in Chapter 9 would involve a t-test as well, but this is a matched t-test or a paired t-test. And so this would be an example for here. For example, it says the actual high temperatures and the real high temperatures that were forecasted the day before. So we're going to take a look at comparing those to see if there's really a difference between the two. So if you open these in StatCrunch, because these are a matched pair, you're still clicking T, but this time you're clicking paired. In this particular problem, it's asking us to find a 95% confidence interval. So we would simply click 95, click to compute, and here you can see it's negative 8.05 to positive 8.05, or negative 8.0 to positive 8.0. Meaning again, because the interval includes 0, that basically there's not a whole lot of difference between the actual and forecast temperatures. They could go 8 degrees either way, the difference between the two, but we still would say that they're negligible. The mean difference is really still 0. Okay. Here's another example where you have students that were, the same group of 8 students were allowed to take a test twice. They're taking a test to see if retaking it would affect their score. We want to test the claim if the differences have a mean of 0 using the 0.5 significance level. So we copy the data into StatCrunch, click T-statistics and paired. So we have the first and the second, and we're testing to see if the average difference is 0. We're going to go ahead and do that. Our p-value is 0.0091. Now, we're comparing that to 0.05. So because our p-value is less than alpha, we will reject HO, which means we're finding that the mean difference is not 0. In other words, that retaking the test has some sort of effect on the score. Hope that helps.